Hey guys, welcome back to the channel. Um, Today I'm going to be talking about a lead code problem called maximum subarray. If you're not familiar with lead code is basically programs involving some sort of algorithms and data structures, I guess. They're essentially like simple programs which take an input and give you a desired output. And they really involve like some kind of critical thinking. So that's why lead code is famously used by tech companies in interviews because it just tests your intelligence. So leadcode.com is one of the platforms which have like practice problems for you to solve and just try out. So the particular problem that I'm solving is an easy problem, which means it should not take like too much of effort to solve it. But the reason I'm making this video is to show off something called Kadane's algorithm, which I think is really cool. So let me explain the problem statement and then we'll get into it. So the description of the problem is you're given an array and you want a contiguous subarray, which means a subarray of elements which are in one straight line. Like you can't skip elements, they have to be in a straight line. And any possible subarray, like this is a subarray, whatever, right? So any like possible subarray of this array which has the maximum sum. So that's the question, right? So the brute force method of solving this is essentially looping through every possible subarray, which is like you start from here, this is one subarray, and then this, and then this, and then this, all the way to this, right? And then you start from this, and then this, and then this, and all the way to that, and so on and so forth, right? So you go across all the possible subarrays and you find the maximum sum and you return it, right? So this is an O of n square time complexity and is too slow for the sake of interviews, right? And it's just too slow in general. Like O of n square is like always bad. So there is a way to solve this in O of n, which is what we're going to be talking about, and that is Kadane's algorithm. And I thought it was really cool, so that's why I'm making this video. So I'm gonna try and explain it without actually showing you the solution, and then we'll see if it matches, right? So what Kadane's algorithm basically says is you don't need to calculate all of the combinations. You just need to know like so it okay, I'm going to start coding and then I'm going to explain this to you as I run along. All right. So first of all, we're going to initialize two variables. So int current sub array, and we're going to initialize this to the first element of the array. Then we're going to do int max sub array, and we're going to initialize this to also the first element of the array, right? And we're going to do a simple for loop, right? Now here's where things get interesting, right? So current sub array equals math dot max, right? Nums I and current sub array plus nums I, right? And max subarray equals math.max current subarray and max subarray. All right, that's it. Let's see if this works. Accepted. Wrong answer. Input 1, output 2. Okay, my bad. So this has to start from 1. There we go. Okay, so let me explain what I just did. So essentially, we start from the first element, we add the second element, and we see if the sum is greater than or equal to just the first element alone, right? And then this is the sum. We add an element and see that does it increase the sum or decrease the sum, right? If it increases the sum, that becomes the new sum. If it decreases the sum, then we know that, well, first of all, we know that then that cannot be the sub-array that we're looking for, right? Because like negative numbers are bad. So the first line, current sub-array, they both start from num0, right? So the first line, current sub-array, it is a math.max of nums I and then current sub-array plus nums I, and I starts from 1. So it checks like what is bigger, this or the sum, right? At any point of time, if the element in consideration is bigger than the sum of the element plus everything that's come behind it, you know that it's time to discard that whole subarray, because the singular element which we just found is bigger than the entire subarray which you have been calculating, right? So you don't need it. Like you just need the one element. So you update it, right? And then max subarray is a simple counter which just keeps the maximum count that you've found. So every time you get this, yeah, it just like keeps the maximum count, right? And that it returns it. So what I think is like really cool about this algorithm is how it checks like whenever. So how this would work is, so let's say you had -2 and 1. So it starts from -2. Then you add 1. So it becomes -1, right? Well, okay, let me print it out. It'll be easier to explain. Current sub array is right, and these should be at the bottom. This shouldn't be here, right? So so let's look at what we have here, right? So we start off from num0, right? Or wait, should I actually, yeah, I should put it here, to be honest. Yeah, so we start from okay, so we start from the first one, that's -2, and then so current subarray is -2 because we just have one element, and then the max array is -2 because that's all you have, and then current subarray is 1 because the sum is -1, but the element is 1. So the element itself is bigger than the subarray. So you don't need the subarray, because any subarray bigger than this would benefit from just this element being there than these two elements being there. So you just start from here, right? And so max subarray is 1, right? And yeah, and then max subarray is 1, and then current subarray is -2 because you add -2, right? And then max subarray is still 1, and then it goes to current subarray is 4 because -2 plus 4 is 2, but 4 is more than 2, so once again you just start from 4, and then max subarray becomes 4, and then current subarray becomes 3 because 4 plus -1, max is still 4, and then you add 2 to 3 and you get 5, and then max becomes 5, you add 1, you get 6, max becomes 6, and then you add -5 to 6 and you get 1, but then max remains 6, and then that's it. I think in the last one, so what would happen is you would like start again from here, and then this is like less than 6, so the answer is just 6, and then that's it. So that's how you get the answer, and I think it's a very smart way of solving this problem. I was like, I thought it was like very interesting and very intriguing, the way this algorithm works, and so I thought I'd share it with you. You can probably use the algorithm for a different kind of problem statement than just this, but that is what it generally says. So if you go to the solution, Kadane's algorithm is a type of dynamic programming. So dynamic programming is essentially a type of programming where you break problems into subproblems and you kind of like store information so you don't have to recalculate stuff. So this is not a technical example where you use a hash map, but I did think it was pretty cool the way they solved it, and it was very very intuitive. So I'm not gonna go and like read the whole thing out. I'll paste a link in the description of this problem. Go and check it out, right? You might not have the solution if you don't have LeetCode Premium, but hey, at least from this video you should be able to implement what I just showed you here. And yeah, that's it for the video. If you enjoyed, leave a like, subscribe. I might make future videos based on algorithms which I find interesting. And yeah, that's been it. I'll see you guys in a future video. Hey do, bye for now. Have a great day.